Okay, so our last section in trigonometry, the cosine law. So the cosine law describes the relationship between the cosine of an angle and the lengths of the three sides of any triangle. And once again, we use the cosine law when we don't have a right triangle. Okay, so we don't use when we can't use SOHCAHTOA, then we would want to either use the sine law or the cosine law. Okay, so for any triangle ABC where A, B, and C are the lengths of the sides opposite to angle A, angle B, and angle C respectively, the cosine law states that C squared equals A squared plus B squared minus 2AB cos of C. You can express the formula in different forms to find the lengths of the other sides of the triangle. So if I want to find side A, then I would go A squared equals B squared plus C squared minus 2BC cos of A. And if I want to find side B, I would go A squared plus C squared minus 2AC cos of B. Now on the formula sheet, you're only ever going to get one of these formulas, and it will most likely be this middle one here. So it would be to your advantage to recognize the patterns between all of these and how you can come up with the ones that will find the other two sides. Okay? Or of course you could just take your diagram and relabel all the sides so it suits your formula. Okay? But just so that you can see some patterns here. If I'm looking for side C, then I'm going to square the other two sides and I add them. So A squared plus B squared minus, and then A times B, which are my two other sides, multiplied together, times the cos of C, so the angle opposite the sides that I have over on the left. If I'm looking for A squared, then I would go B squared plus C squared, the other two sides squared, minus 2 times B times C, so B times C, cos of A. And A being the side opposite the side A being the angle opposite the side that I'm looking for. And then if I wanted B squared, I would go A squared plus C squared minus 2AC cos of B. So the two sides squared that are not B, minus 2 times A times C, and then cos of B. So if I was going to do this, and let's say on a formula sheet I have A squared equals B squared plus C squared minus 2BC cos of A, and let's say I wanted to find C squared. So I would go, all right, well, C squared equals, and then I would square the other two sides I don't have and add them. Okay, so I'd keep the same format as this formula. Minus 2, instead of going B times C, it would be A times B, and then cos of C, which is opposite the side I want. Okay, and then if I wanted B squared, I keep the same format as these. I'd square the other two sides that I don't have, so A squared plus C squared minus, and then 2 times A times C, and then cos of angle B. Okay, so you don't have to memorize the formula because that'll be on the formula sheet, but you would want to know how to come up with the other two. Okay, or like I said, you would want to just rearrange your letters on your triangle. Okay, now before we go over the table, I just want to show you how you can manipulate the formula to find an angle. So let's say that I want you to find angle, or let's say you want to find angle A. Okay, so you would want to use this version of the cosine law. And because you want angle A, you would want to solve for cos of A. So we would want to solve for cos of A. Okay, so what I would do then, because I want to isolate this to start with, I would take my B squared and my C squared and I'd move them to the left. Okay, so I would get A squared minus B squared minus C squared equals negative 2BC cos of A. And then because I want to isolate cos of A, I would divide both sides by negative 2BC. And so this will reduce. Okay, and what I will have then is that cos of a is equal to a squared minus b squared minus c squared over negative 2bc. But I don't want the negative in the denominator. Okay, so what I would do, I would take the numerator, I'd pull out a negative, which would make my a squared negative, right? Because a negative times a negative would bring me back to a positive a squared, and then this would become positive and this would become positive. And so then I can make a negative divided by a negative a positive, right? And so the cos of a is equal to, and I'm going to go b squared plus c squared minus a squared over 2bc. And of course, there are the other two versions. If I want cos of b, then I would go a squared plus c squared minus b squared over 2ac. And then cos of c is equal to a squared plus b squared minus c squared over 2ab. Okay, and once again, there are patterns here, all right, that you could use to help you remember the other two formulas. Now, this version of the cosine law will not be on a formula sheet, okay? So if you want to use it, you can memorize it, which I would recommend, because if I'm looking for an angle, it's easier to use this. But you don't have to, because you can always use these versions to come up with your angle. You're just going to end up having to do some more isolating, that's all. Okay, so when do we use the cosine law? All right, well, let's go back to congruency conditions, okay, which we were looking at with the sine law. And we've got two other situations. And in both of these cases, you would want to use the cosine law. So let's say that you are given two sides and an angle which is contained. That means that that angle is in between the two sides that you are given. Okay, so now you have side, angle, side. That's your congruency. Okay, then you would use the cosine law. Okay, so if you've got two sides and a contained angle, then you would use the cosine law. Okay, and the second situation would be if you were given all three sides to your triangle. Okay, if you're given all three sides to your triangle, then you would use the cosine law. So that would be side, side, and side. Okay, so in the first situation, you would most likely be looking for a missing side, and on the second situation, you would be looking for a missing angle. Okay, so I will end this discussion here, and then on the next video, we will talk about proof.